All right, so what do you notice or wonder about the two functions below? In this unit, what you're going to want to do is you're going to want to factor anytime you see these type of rational functions. Okay, so right here, we're going to factor this guy. We're going to say a times c, which is -8, and b, which is -2. What two numbers can I multiply together to get me -8, but add together to get me -2? Multiply together to get me -8, but add together to get me -2. Okay, -4 and +2. Okay, so I'm going to rewrite this as x minus 4 and x plus 2. And then we're going to factor the denominator. So a times c is going to give me 6. B is 5. What two numbers can I multiply together to give me 6, but add together to get me 5? That's going to be 3 and 2. I can write this as x plus 3 and x plus 2. Do you notice how there's a repeat in the top and the bottom? Well, we learned last Friday that we can cancel these out and rewrite this as x minus 4 over x plus 3. Notice how now this equation is the exact same as this equation, except this equation has a hole at x equals -2. Yep, that's a hole at x equals. Okay, so today we're going to talk about holes and vertical asymptotes. Okay, so we just asked a good question of what is a hole. If you look at these two graphs, okay, it's the same functions that we were just dealing with. There's only one difference, and that's right here. It's kind of hard to see, but it's this little hole at x equals -2. So it's the same graph, but a hole at x equals -2 on the f of x function. Okay, that's this guy. So what could have caused that? And that's the x plus 2 factor we canceled out. Okay, so the two things that are going to impact domain restrictions. Okay, so we will say that you could plug in any real number except for anything that has to do with the vertical asymptotes or anything that has to do with the holes. And again, we're going to go through that a little bit later. We're just going to identify what a vertical asymptote is and a hole is. So what causes rational functions to have domain restrictions? That's going to be vertical asymptotes and holes. Coming back to that function that we started with today, so the one that looked like this was on your paper. This is after we factored it, right? So we said this was a hole when we canceled this out, right? So when do they occur? When there's repeat in the numerator and denominator. So how do you find them? You factor and then cancel them out. All right, now vertical asymptote is kind of similar. You're going to have whatever's left over in the denominator. So when do they occur? When the lines don't approach a certain y value. Oh, I'm sorry, x value. X value. And how do you find them? It's whatever's left in the denominator that's not a hole. All right, so for instance, the vertical asymptote of this original function is going to be x equals -3. So notice how we switched the sign of whatever is left in the denominator, and that's the vertical asymptote. For the hole, it was going to be x equals -2. Okay, so again, we switched the sign of whatever we canceled out. That's going to be the hole. Okay, so a times c is going to give us 9. B is going to give us 6. What two numbers, if I multiply them together to get 9, add together to get 6? What is that going to be? 3 and 3. So I can rewrite this as x plus 3 times x plus 3. On the bottom, we're going to factor. A times c is going to give us -9. There's no b term. Okay, so that's going to be 0. What two numbers can I multiply together to get me -9, but add together to get me 0? 3 and -3. So it's going to be x plus 3 and x minus 3. Now, you see that there's a repeat in the top and the bottom. So we're going to cancel one of those out. That means that it's going to be a whole at x equals, remember, we're going to switch the sign, -3. And then we have a vertical asymptote at x equals +3. Okay, the signs do matter. This one, and then I want you to tell me what the vertical asymptote or the holes are. Okay, so if I factor this, I can't do the a times c thing because it's not a square. Okay, so I'm going to take out the greatest common factor. This is going to give me -2 as the greatest common factor. When I divide -2x divided by -2, I'm going to get x. 8 divided by -2 is going to give me -4. In the bottom, I'm going to do the whole a times c thing. I'm going to come over here. I'm going to say a times c is going to give me 8. B is going to give me -6. What two numbers can I multiply to get me 8, but add together to get me -6? That's going to be -4 and -2. So it's going to be x minus 2 and x minus 4. So what are the vertical asymptotes? What are the holes of this function? What's the vertical asymptote going to be? Okay. Okay. The vertical asymptote is going to be 2. Good. Okay, so vertical asymptote is x equals 2. Hole is going to be x equals 4. Okay, so Jacqueline wrote a possible equation for the graph below based on the vertical asymptotes and the holes. So Jacqueline's equation is x plus 4 divided by x plus 3 times x plus 4. So in Jacqueline's equation, where should there be a hole? At -4, right? Okay, and then where is there going to be a vertical asymptote? Okay, so that's in Jacqueline's equation, right? Now let's actually look at the graph. Now there is a vertical asymptote right here at x equals -3. That's good. Is there a hole at x equals -4? No. Where is there a hole? Over here. So like, let's call this guy x equals 4, right? But what about this other dotted line? Did she include that? Is there another vertical asymptote in her equation? No. Jacqueline messed up, right? Okay, so she got the wrong hole and forgot a vertical asymptote. So we're going to write a more accurate equation than what Jacqueline did, okay? So we're going to keep that x plus 3 in the bottom. And then we have x minus 4 in the top and in the bottom because it's a hole. And then we need another vertical asymptote. So let's just say this guy is 6, right? So we're going to say x minus 6. So that would be a more accurate equation for what we got going on. All right, so what relationship do you see between the equation and the zeros on the graph? So what's the x-intercept for this guy right here, this first one? Okay, so it's at 4, right? All right, and this one, what was the x-intercept? 3 and -2, right? And then this guy, what's the x-intercept? 5. Okay, so where do you see the connection? It's in the numerator. All right, the biggest thing, and we're not including the hole, right? That's not an x-intercept. The biggest takeaway that I want you to get today is this little like chart that I'm about to draw. You're gonna have a 0 in the top. If you have a hole, it's gonna be in the top and it's gonna be in the bottom. And then vertical asymptote's gonna chill in the bottom. These are the 3 things I want you to know. Okay, so there's another thing called a horizontal asymptote. And we're gonna talk about that in just a second. Going back to this whole like equation that we had at the very, very beginning. When we had this whole like x minus 4, x plus 2 over x plus 3 over times x plus 2. And we already identified that the hole is at -2. There's a vertical asymptote at -3. Now we're going to talk about the horizontal asymptote. Okay, so really quick, I'm going to graph this for you so that you can see the different parts. All the sniffles, all of them. Okay, so do you see how at x equals, I'm going to make this super cute, x equals -3, there's a vertical asymptote. You see this blue line, vertical asymptote right there. Okay, at x equals -2, if we come down here, it's not going to show you a hole. It's not going to automatically be on there. What you got to do is you got to go to your table and you'll see that it's undefined. Does that make sense? Okay, so it won't just automatically say it. You have to actually look at the table and that'll tell you where it's undefined. Okay, now horizontal asymptote, that's going sideways. Remember, horizon is horizontal. Vertical is going straight up and down. Okay. Yeah. If you forget that, just think of like vertical as in like jumping. Okay. So horizontal is going to be this way. Okay. So what's the horizontal asymptote? Can anybody tell me? The horizontal. Or the vertical. It's 1. Okay. And the way that you find the horizontal asymptote is if the horizontal asymptote is the ratio of the leading coefficients if the degrees are equal. So if the exponents are equal, then you're just going to take the numerator and the denominator, and that's going to be it. The leading coefficient. Yep. Yeah, go ahead. Okay, so if they are not equal, we're going to add the term to a numerator and denominator so that the degrees are equal. If we add a term, it has to be 0 in order to keep the same function. And we're actually going to see this in just a second. Okay, so for instance, and this is in your packet, we see that our numerator and our denominator's our degrees are the same, right? That means that I'm going to take the coefficients and divide them. So I'm going to take 2 divided by 1, and that's going to give me a horizontal asymptote at y equals 2. Now, here's another instance. So the second one, the degrees are not the same, right? No? Okay, so this case, the denominator is bigger. Okay, so the denominator is larger. So that means that y is going to equal 0 for our horizontal asymptote forever and always. So if the denominator is bigger, y is going to equal 0 for your horizontal asymptote. If my numerator is bigger, then there's going to be no horizontal asymptote. These 3 things you kind of want to memorize. For the horizontal asymptotes, the denominator's bigger, y equals 0. Numerator's bigger, no horizontal asymptote. Or what you could do is you could just graph it and kind of tell, like we saw in the last one. You could kind of see it. All right, so on the first one, what is your horizontal asymptote? Y equals 2. Okay, so it's like this line right here. Okay, what about on the next one? What is that going to be? Y equals 0. So again, this line right here. And then this one, that's going to be none. Okay. Ta-da!